Hello, this is a brief demonstration of the term project for Dr. Michael Adams' ELEC 586 class at University of Victoria. For my project, I have created a basic first-person shooter game using only openGL and the GLUT utilities tool library. So we'll begin with just a short demonstration. As you can see here, the running of the game requires both the actual window generated by openGL, and any information regarding the game itself requires the terminal from which the game was run. For example, the player's points or health, or the health of zombies, or whether you missed or actually hit your target. So the game has just been loaded. As you can see, the necessary files for the weaponry and the skybox and the level have been loaded. The game initially, when started, sits in an innate state waiting for the user to press enter to initialize the game. So we'll press enter and the game will begin. Now you can see the crosshair has appeared in the middle of the screen and I'm able to move around. I can walk using the WSAD controls, as are fairly common in most video games. I can look around the map using my mouse control. If you'll notice, ignore the zombie for now, but if you'll notice that if I walk around the map, there's a border here. If I walk up towards the border, I can't actually go through it. I mean, my gun can, but the position of the player can't actually go through the walls. The same with the floor. By pressing the space bar, I can actually perform a jump. And you can see as I return back down to the ground, I can't actually go through it. That is due to collision detection, which we'll look at a little later. But in another example, going towards the, I suppose, the warehouse here, I can walk towards it, but I can't actually go through it. Same with the silo. Oh, but I can go through the floor. Small glitch there. It's just something to do with the collision plane. But also the same with the little dome here. I can't actually go through it. So as you probably noticed, at the beginning of the game, a zombie appears. I'll press the tab button, we can actually restart. So I'll restart there, so my position is randomly generated, so is the zombies. And if you look at the terminal there, it tells you where the zombie is. It also tells you your starting health, which is 250 points. The number of actual points I've acquired is 0 because I haven't killed any zombies yet. The zombie itself is simply just a bunch of boxes I created in Blender and created a simple animation for it. That's the walking there. If I let him get close enough to me, he switches into an attack animation. See the hands flailing there and my health going down? That's a collision detection has occurred. The zombie has realized that he is close enough to me to begin attacking me. The new animation plays and my health decreases. Now on the mouse, the right button, if I press the right button, it goes into an aim mode. There's two modes, both from which I can both fire the gun. So this is normal, sort of at the hip mode. See, I can fire my gun. You can see I actually hit the zombie there. That's fine. Shotgun has a wide spread. You see I can fire the gun from the hip, as it were. And I can also go into the aim mode. So this brings the gun up to the player's view. And what it does is this actually greatly increases the precision of the weapon. So now if I fire, and the zombie dies. The zombie has a death animation, which you just saw play there. He's obviously just a little stuck on part of the dome there, but the death animation plays and the zombie is now out of the game. As soon as that happens, a new zombie appears. And you can see again in the terminal there that the zombie has died. I've got 1 point. And the new zombie was generated at 21, 11, and 8. And again, see how he sort of follows me around. That's due to, we'll look at it a little later, but some ray tracing. Essentially, the zombie calculates the direction between himself and myself and just rotates and walks towards me. Not a very smart AI, but that's all we're going to get for now. There we go. Okay, so currently I'm alive and I'm playing, and I forget what my health is at, about 26. If I allow the zombie to kill me, so he comes up, goes into his attack mode, oh, there we go. So he killed me. Now I've gone into heaven, essentially. The map is comprised of a skybox. Essentially, it's just a bunch of images, as you're seeing now, sort of splayed together. There was a small difficulty with getting the pictures to actually line up. That's why some of them are not quite perfectly smooth, but some of them are. Like for example, this sort of edge down here, sort of where the cursor is tracing, there's actually two images that match up there, and because they match up so well, it doesn't look like there's any edge whatsoever. That was sort of the same with this one. That was sort of the goal with all of them. It just wasn't quite perfect. But this is sort of the box that sort of surrounds the map at all times. Now, if I press tab to reset, there we go, the map comes back, I'm back on the ground, and a new zombie appears. Now, so let's kill this zombie. Oh, actually, back into aim, kill him, so that's 1 point. Now, oh, he appeared behind me. And you can notice that my health is returned back to 250 there when the game restarted. Now, if I'm kind of bored with how difficult this is, I can press the backspace and generate a new zombie. Wait, 24, 7, and 4. Oh, yeah, now there's two of them. So now there's two zombies. So this just makes things a little bit harder. Simply the same principle. It's just a little bit more difficult. Now, if you notice, when I tried to fire there too often, each weapon in the game has what's called a reload rate, essentially. Between each shot, there's a certain amount of time that needs to pass before you can fire again. This is to simulate the real-life differences between certain weapons. So, if I go out of aim here, you can clearly see this is sort of a shotgun. If I change weapons by pressing key number 2, so now I bring on my AK-47. Go back into aim mode, and we'll fire at the zombie. See, I can fire quite a lot faster with this gun. Because it's a semi-automatic weapon, that sort of makes sense. And you can see the zombie's health actually goes down by 10 using this weapon, whereas with a shotgun it goes down by 50. Oh, I'm being attacked. Okay, now there's two of them. Alright. And you can see sometimes there in the terminal, right after the fired command, or fired thing pops up, you can see it says miss. Now, in the real world with weapons, they don't always fire exactly where you're aiming at. Bullets spin and are blown away by the wind, and sometimes you're just spraying bullets around and they're not very accurate. To simulate that, what I've done is so the way the firing works is it's a collision between the ray of where the camera is pointing and the object I'm looking at, in this case being the zombie. Now, if I'm looking at the zombie and I fire, there's a ray directly from where I'm looking to him. However, to simulate the sort of inaccuracies with weapons, what I've done is I've randomly generated sort of values that, what's the word I'm looking for? Permute the ray between where I'm looking and where the target is. That's why sometimes you'll see, even though I'm aiming right at him, let's see if we can get one. There we go. See, it said miss, even though I was aiming directly at him. It's to simulate how unreliable certain weapons are, and certain weapons are more reliable in this game. For example, the AK-47, it's far more accurate. So if you're aiming at him, you're a lot less likely to get a miss. Now, just like I think I may have mentioned partially, but just like in the real world, firing from the hip is a lot less accurate. So each weapon has two precision levels. One from when you're firing at the hip. Oh, I'm hitting both zombies at the same time. Oh. So from when you're firing at the hip and when you go into the aim mode, you actually get a higher precision with your weapon. So you're more likely to get a hit. Now, as you can see there, what just happened is that I got a game over. Essentially, the game is set to 5 zombie kills, and you've won. So I've survived the zombie apocalypse, and I've won. So now I have the option to either press escape to quit, or I can press tab to sort of restart the game. There we go. Restart, and my zombie comes in somewhere there. Now, using Blender, I took the meshes for both of these weapons just from the internet. It was faster than just make them. I found some free ones on an object file website. But I've loaded these into Blender, and what I did is I created basic animations for them. That's why you're seeing how when I pull the trigger, the gun actually recoils. I can do the same by pressing R. It creates sort of a Nintendo 64 James Bond style reload where it actually just goes down like that. I'll go into Blender and I'll show you a little bit more about what I mean in a second. It's the same with the animations of the zombie. Alright, so if I press escape, the game ends. And we can look at Blender. So this is where you can see how I've just loaded in the mesh of the basic shotgun from the game there. And I didn't do really anything to the gun. I didn't add any materials or textures to it, and just the gray was simple enough. But I added some basic animations, which are why you see in the game they recoil and reload and such. And if I just press play here, you can just see how, there we go. It's just sort of one sort of pattern. It's for one. It's a total of 38 slides, but both the animations for both firing and reload are actually in the same animation string. So if so we see frame 11 here. We're right in the middle of the recoil for the weapon. We get to frame, I think it's whatever that's 18. Now the reload, the reload animation begins. See, it's all sort of stored in one array of frames, essentially. And this is how the animations work for both the weapons and the zombies. The zombies have 3 animations. They have their walking, where the arms and legs swing. They have the attacking animation, where the arms sort of flail about. And then the third animation is the death one. And they're all in the same array of frames. It's just where they start is what you see on the screen. So we'll just go a brief look through at some of the code here. So starting with the main file. Alright. So the main program starts, and it provides you with, you haven't seen it, but an option essentially. So the object files for the animations for the both of the weapons are quite large, and it takes quite a while to load in, which is fine if you actually want to play the game, but if you just want to do testing or development, the wait is quite obnoxious. So I've created just a very basic, just a rectangle essentially as a development weapon. And so in the main function, it just provides you just the option like, oh, I'd rather not wait to load in the object files for the 2 actual weapons. I'd rather just use the development weapon. So if we load it, well, let's see the terminal. So I think the test weapon, just press 1. I can see it loads in there the animations for the zombies and the skybox and the basic weapon. Okay, there we go. So you can see it's just a really simple test weapon. It has the same properties as the shotgun, so it's slow to reload, slow to fire, such like that. It's essentially the shotgun. It's just it doesn't have all the fancy shapes. It just makes it a lot faster to load in. So the game actually starts, and we get all of our openGL and GLUT functions as you would expect, just creating the window and the callback functions. The initialization function, which is somewhere up here. So the initialization function, this is where the actual loading process for the map. The map is down here. The test weapons and the shotgun and the AK-47. This is where and the zombie. This is where the loading actually takes place. Now, GLUT doesn't provide any form of loading object files of themselves, so I had to write my own. I looked at the object files and I looked at exactly how it works, and I wrote my own loading function. So let's start here with, okay, so let's say we're just doing the development mode here, so just the test weapon. So the first thing that it calls after the basic initialization stuff is it calls this load animation function. So the load animation function, it cycles through all of the frames for the animation and loads them in one by one. Let me just pull up here. You can just see. Yeah. So you can see here, these are all the different frames for the AK-47 animations. There's 38 of them. So when I call this load animation function for the AK-47, I pass into it that there are 38 frames it needs to load in. So it cycles through from 0 to 38, and it generates the file name for each of those 38 animation files, and it loads them in one by one. What it does is it creates this object loader object here. Now this is where I actually wrote our object file reader. So in this object, now we're looking at the CPP file here, but so the load function, essentially it reads the file line by line, as you can see here. So this is where the while loop starts. So it looks for each line of the file, and it splits each line into tokens using this split space, so split by space function, and it looks at the first token. Let's look at one of the object files. So if you look here in object files, anything that starts with a V is a vertices. We scroll down. So T is for textures, VT is for texture coordinates, VN is for normals, so face number, whatever this would be, 874, has the normal vector specified by these three coordinates. The F signifies a face. So the way this works is this is face number 273. You can see that each of the three ends with 273. Now face 273 is comprised of vertices number 386, 388, and 389. The texture coordinates in the middle here, 351, 352, they specify how the texture is mapped to this particular face. So if we look at the code here, it actually reads and it looks through the first token of each line, and it decides what to do there. So it loads in a vertex, realizes that there's a normal, so it loads in a normal. On and on, it goes to the face, it finds a texture coordinate. Now, looking at the object file again, this line here, it starts with mtl lib. This essentially says the materials needed for this object can be found in the file ak47.mtl. For the weapons, I don't actually use any materials, but for the map, we do. I can see here that the mtl lib calls the load materials function. This function is fairly similar to the load, but it reads the .mtl file associated with this object. Let's pull one of those up. Now it's a fairly similar process with the MTL files. These are simply just properties of the particular material. This material is called null.001. I don't know why it's called that, but that's just how Blender generated it. So this is the name of the material, and these are its specifications. I think this is like ambient light diffuse light, the alpha value, and certain things you can map textures to. I don't have anything actually mapping textures in the game, but it is possible if you spend the effort to actually write a texture loader, which I didn't have time for. So if we go back to the load function, once the actual OBJ file and all the material files have been loaded, the load function calls this draw model function. Just do this. Go to definition, there we go. So this function here, it's a little deceiving. It doesn't actually render the model that's been loaded in. What it does is it creates a call list. Now, in openGL, call lists are essentially, it's just a set of instructions. So it says from this point here to this function call here, GL endList, is it creates a list of instructions to be performed later. So this draw function here is fairly self-explanatory. These lines here, actually we start by iterating through each phase, and then for each phase that's loaded into the model, these statements here, what they do is they load the values that we read in the MTL files. For example, get the ambient light value and get the, I forget what KS is for, but essentially it loads all of the properties for the materials. Once the materials are loaded and it's time to actually draw, or say the commands to draw the model itself. Some models have quads, some have triangles, some have both. So this is simply just a basic draw function for both quads and triangles. The rest of the functions in this file are just sort of support functions for splitting strings and generating the face objects and such. Nothing terribly interesting. So back in the main function, so when we loaded in the weapon, it loaded in each of the animation frames. So there were 38 of them for this particular weapon. And then it creates a new weapon once all of those are loaded in. So this new weapon has, so the animations that were just loaded in are stored in this animation vector. This is sort of the orientation for where the gun is to sit in relation to the perspective of the player, the rotation, and these two vectors are for when you press the aim function. So the weapon's actually brought more into the viewer's eyes. This is sort of the rotation, so it sits at these coordinates and it's rotated by -90 degrees. And for the shotgun and AK-47, there's the same sort of structure. The values for where it sits and how it's rotated are slightly different. It's just because of the gun itself. So once those weapons are created, they're loaded into this weapons vector here, and the animation vector is cleared. So now it's time to create the actual player. So the player is created here. This function, so this starting point vector here. So this change, what this does is essentially just takes a vector and writes new values into it. So this choose_position function returns a vector. If we go look at that. So the choose_position function, all it does is it picks random coordinates for a spawn point. And to prevent a zombie or the player from spawning inside the silo or the warehouse or outside the map, I've written these brief functions here. So with the map I generated, I could tell where the silo was, where the dome was, and the size of the map itself. So it generates a safe spawn point for the zombie and for the player, and returns that vector 3D object, which is used here as the starting point vector. So the player is generated. The player's name is Nick. He's given this starting point, and he's given the vector of weapons. This weapon 0 is just what weapon he starts with. So in this case, because the shotgun was pushed onto the weapons vector first, the weapon that you start with when the game starts is the shotgun. Now the zombies are loaded in much in the same sort of fashion. The animations for the zombies are loaded in, but the zombies aren't actually made just yet because we don't want them made while the player is still in the inanimate mode. So here the map is loaded in. Now this parameter here, call planes, if we go back into Blender, I can give you a brief, I can show you. So this is the map that I made in Blender. So you can see it's just fairly simple, just a box and dome and a silo, nothing too special on the walls. Now, each of these things, so if I click on the ground here, you can see here that the material here is called green, or I spelled green wrong, but it's called green. It's just a green material. So when it's loaded in, the object loader reads that this is green, and then it's got the green property. Same with the brown walls, same with the blue for the dome and for the silo and such like that. If you notice on the other side of each of the walls and on the ground, and actually you can see on the top of the silo, and I think if I just move this, so there we go, so you see now it's black. But there's actually two of everything. There's two warehouses, there's two domes, there's two silos, two floors, everything. So if I move this wall here, you can actually maybe get a better sense that there's actually two. So one is red and one's brown. All of the red ones, for all the walls, for the silos, for everything, they have a material name here called collision. Now this is kind of important. Back there. Actually, if we go back into the object loader file, you can see when a material, where is it? Here it is. So when a used material is called in the object file, so essentially it's saying this object here. So as you can see in this object file with the AK-47, it says use this material, and then this is the name of the material. So for the map there, when the object loader sees this used material, it checks to see if the name of the material is collision. If it happens to be collision, this object is not actually rendered. So anything that's red is not actually rendered, it's not drawn by openGL. What it does is it stores it into this, that's somewhere. But essentially it stores it into a collision plane vector. So every face that is red, that corresponds to a collision material, is not drawn. It is stored in a collision plane vector. If we go back to the main here, now, so what happens here is when we load the map object here, this map is just another object loader object. So we're saying load the map collision.object into the map object here. And we're passing this call planes parameter. And what happens is that the object loader, when it detects a collision plane face, it stores it into this vector here. So while we're walking around, if the player, if he bumps into one of these collision planes, for example the wall or the floor, he's no longer allowed to move. If we look in the player, actually okay, we'll go back to that. So here we just initiate the skybox where you can see the fancy clouds and such. Alright, so the display function is where actually most of the action happens here. So here we actually see like the skybox being drawn with a size of 200. Now most of the game operates on an update and show function. So the main function, I guess the game function if you want to call it that, has an update and show function, and these update and show functions control the update and show functions for every other object. For example, a zombie, it has an update and show function which are controlled by the main update and show function. So if we go to the update function here, you can see that, like for example, the levels which is where the maps are controlled by. It has an update function. The zombies, they have an update function. This is where the actual control of the objects takes place. If we look at the update function here for the main, so if the player moves, which is fairly likely, then the level is just updated, it's redrawn. Nothing too fancy. So every time the update function is called, we iterate through the list of zombies that are created. So if there's 3 zombies, it looks at each zombie and it asks, it calls for an update of that that particular zombie, zombie I here. Now the zombie update function, here we go, it's fairly long, but essentially it returns a true or false. The true or false dictates, for example, as you can see right here, if the zombie just died. Now the zombie dies, if you remember when we're playing, if we shoot it, you can see that the zombie's health goes down from 100 to 80, 90, or whatever. When it reaches 0, and this update function for that particular zombie is called, it returns true. So what this says is that, oh, in this call of the update function, the zombie has died. So in the update function here, if this big long function here returns true, we know that that particular zombie has died, so the player gets an extra point. We check to see if the maximum number of points for the game has been achieved. If so, we call it game over, which essentially just waits for you to press restart or escape. If not, if you've killed a zombie but the game's not over, we add a new one. Alright, so after that, again we iterate through each of the zombies and we look to see if there has been a collision. Now the game operates on like a collision detection system. The player and all of the zombies have what are called a collision sphere. It's essentially an invisible sphere around it, with the center sort of at the center of the player or the center of the zombie, and a radius. Now, we call the zombie set attack function, and we pass to it, for each zombie, the collision sphere for the player. So we're passing that circle to the zombie set attack function. So if we look at that function, essentially what we do is we check, okay, the zombie's not dead, good. Now we do a sphere-sphere collision. So both the zombie and the player have a sphere, and this collision class here is it looks at the sphere of the zombie, or the player's center, and the collision sphere of this particular zone. So player's collision sphere and the zombie's collision sphere, and it detects whether a collision has happened, essentially whether the spheres have overlapped. If that happens, then the zombie is close enough to you to attack you. So this is attack variable gets set to true. If not, the zombie just keeps walking. I'm going back here. So if the attack is happening, the player's health is reduced by the strength of the zombie. Each zombie has its own strength. For now, just because all the zombies are the same, all the zombies have the same strength, but you could create a boss zombie where it damages you twice as fast as you wanted. But for now, it's just decreased by 1. So each time this function is called and the sphere-sphere collision returns true, the player is reduced in health slightly. If the player's health equals 0, the player has died, and that's when you get to sent to heaven, as we saw earlier. So in the player function, there's something relatively similar. The similar process, essentially. So this player update function is what it gets passed from the main function, wherever that is. Here, I forget where it's called. But when it is called, each iteration of the main loop, it's passed to it that vector of collision planes that was generated when we loaded in the map. So each of these red things. So all of these red things get into that vector there. So when this function is called, essentially a new direction is calculated. It's not terribly important. It's just based on where you want to move and where the camera is aiming. But it's not actually enacted yet. So this new position that's created is passed into this sphere plane collision. So if we just go look at that. So the sphere plane collision, essentially, it checks for a collision between the center of the sphere, in this case it's the center of the player, and then it looks at the normal and each of the 4 points of whatever face that is. If it's a triangle, it's just 3 and it doesn't make any difference. Or like P4 equals 0. It doesn't really change anything. So this function iterates through each of the collision planes in the map, and it checks to see if the player has bumped into it. If that happens, where is it? If that happens, essentially a new position for the center sphere is calculated. So essentially what it does is it nullifies this calculation of a new position. So this new position is actually the same as the old position, preventing the player from moving. That's how the collisions happen. There's something very similar in the zombies, in the zombie class, which prevents the zombies from walking through the warehouse or the silo or the walls or the floor or anything to that effect. Go back to the main. The show functions. Essentially, these are the ones that are responsible for drawing, translating, shifting the objects at hand. So if we look at the zombies show function, you can see that this is where the actual, not the drawing. Well, actually, it is the drawing. The translation. So the collision sphere here. This is where. So this any calculation of the zombie being moved or not. The x, y, z coordinates of that position are put into this call sphere vector here, the center vector of the call sphere object, collision sphere object, and we rotate the zombie according to where the player is. And the scale is just permanent, just because it's just hard to make them of the right size in Blender. And this call list function here is what's actually doing the drawing. So this is where the actual drawing takes place. If we go back to the object loader where this draw model function was called, and you remember that the gen lists was done, so this drawing wasn't actually taking place here, it is just stored as a bunch of commands. This is where those commands are actually executed. Frames is passed in via the where is it? Here, this animation variable here into the weapon or the zombie, wherever the loads are. But essentially those frames are passed in via the animations, which are loaded in from the load animation. What else is important? And I think that's sort of the key. So the controls of the position and the weapons and such like that are controlled actually in the timer function. This just makes things a little bit more smooth, and it's a little easier to control the effectiveness of the I suppose you want to say the fluidity of the gameplay. So say for example if I wanted a really chalky, not smooth gameplay, all I have to do is increase how frequent the timer function here is called. So this is 3 milliseconds now rather than 1. So every time this timer function is called, we look at this Boolean array and we check to see, okay, is the W pressed or is the S pressed? And this is where the actual translation of the player takes place. And we can see the player 1 has a camera object, which we strafe, and the translation speed. The callback function's keyboard, wherever that is, are actually reading in somewhere. Here we go. So we're actually reading in the values. So say for example restart, when we press the tab key to restart the game. This is when these are actually being read, but they're not being acted on until the timer function is called here. So G key is 256 size Boolean array, and every time this function is called for key impress, the ASCII value of this key gets put into this value key and put into this Boolean array. So everything is false until one of the values is set to true, but we don't actually do anything until the timer function is called. This just helps with control of the fluidity of the game. You might see in the README that there's actually extra control functions on the keyboard. So these are just for development purposes, which is why they're commented out at the moment. It's just when I first developed the game, you would load in a weapon, but an AK-47, and it would be backwards, for example. These keys here, all it does is allows me to rotate the weapon to a place where it actually looks kind of good from the player's perspective. And if we look at the weapons class here, it's right here. So this test function, if it receives the key J, it just rotates the gun a little bit, moves it up and down, and just so I could put it in a nice position. Once I find a place that works, it just prints out the XYZ coordinates of both the position and the rotation, and then that's where these values in the initialization function, here these values came from. So it's just for development. It's not actually used in the game. We can change the number of maximum kills, so if we want to play a really long game, we could make it 10, 15, whatever. I only set it to 5 because it gets kind of dull after a while, but I can keep going at infinitum. And that's about it. That's sort of a basic walkthrough and a basic demonstration of my Elec 586 project, ZombieHunt. Thank you for listening, and have a good day.